the time you watch this video, Webb telescope might already be at L2. But, is it just a big mirror looking into the cosmos? What makes it so special? Let's have a look at the instruments of Webb. MIRI, NIRISS, NIRCAM, NIRSPEC are the four instruments that make up the cosmic time machine. But, do you know what they are made of? Check out the video on components of Webb's instruments from our channel, to understand the instruments better. Let's get into the video. MIRI. MIRI is the only instrument on Webb that observes in mid-infrared. Since it has to operate at a temperature of 7 Kelvin, it has a dedicated cryo-cooler that cools MIRI to the desired temperature by a two-step process. MIRI is the only instrument on Webb that is made of 4 components. Observing in mid-infrared will allow it to capture newly forming stars, Kuiper belt objects, protoplanetary disks, etc. This potential is utilized by using cameras, spectrographs, coronagraphs and integral field units. MIRI observes in wavelengths ranging from 4.9 to 28.8 microns. Its observable range is 5 times larger when compared to the other 3 instruments. The object used for field of view comparison is Messier 51, commonly known as Whirlpool Galaxy. The white box in the middle represents the main field of view of MIRI. It is 1.9 cross 1.2 arc minutes. In comparison, full moon in our sky is about 30 arc minutes in angular diameter. Field of view of MIRI's coronagraphs and IFUs are much smaller. Watch components of Webb to get an idea on different imaging modes used by Webb telescope. MIRI uses these 3 imaging modes: standard, coronagraphic and time series. Also, MIRI uses 4 out of 6 spectroscopy modes employed in Webb. They are single object slitless, slitted, integral field unit spectroscopy and time series. NIRISS. Near-infrared imager and slitless spectrograph, or NIRISS, is a near-infrared instrument paired with fine guidance sensor. The fine guidance sensor will help pointing the telescope towards desired target with high precision. NIRISS has camera, spectrograph, and aperture mask. It is the only instrument onboard Webb to be equipped with aperture mask. Its observable wavelength ranges from 0.6 microns to 5 microns. That is, visible red light to margin of mid-infrared. This will allow it to detect exoplanets and perform exoplanet transit spectroscopy, which will help identify the composition of their atmospheres. The white box represents maximum field of view of NIRISS, which is about 2.2 cross 2.2 arc minutes. For aperture mask interferometry, it is almost 700 times smaller, with 5.2 cross 5.2 arc seconds. NIRISS employs 2 types of imaging modes: standard and aperture mask interferometry. Also, being a dedicated slitless spectrograph, NIRISS employs only 2 of the 6 spectroscopy modes: wide field slitless and single object slitless spectroscopy. NIRCAM. NIRCAM is the only near-infrared instrument onboard Webb, with coronagraphic and time series imaging capabilities, making it important for many exoplanet studies. It is also a part of Webb's wavefront sensing and control system, which detects and corrects for slight irregularities in the shape of the primary mirror or misalignment between mirror segments. This system provides the telescope with the ability to focus objects that are near and far. Major components of NIRCAM are camera, spectrograph, and coronagraph. NIRCAM has an observing wavelength range of 0.6 to 5 microns. It has 2 different sets of detectors that split the observing range as short wavelength, from 0.6 to 2.4 microns, and long wavelength, from 2.4 to 5 microns. NIRCAM's field of view is made of 2 squares that covers 2 long wavelength detectors and 8 short wavelength detectors. Each square is of side 2.2 arc minutes. It has 3 imaging modes: standard, coronagraphic, and time series. These modes will help NIRCAM in observing the light from formation of early stars and galaxies, young stars in Milky Way, and Kuiper belt objects. The 2 spectroscopy modes used by NIRCAM are wide field slitless and time series. NIRSPEC. Near-infrared spectrograph, or NIRSPEC, is a dedicated spectrograph designed for capturing the spectra of target objects, not 1, not 2, but about 100 spectra at once. It is the first spectrograph in space with this capability. The major components of NIRSPEC are spectrograph, microshutter array, and integral field unit. Since it is a dedicated spectrograph, it doesn't have a camera as an individual component. It operates in an observing wavelength range of 0.6 to 5 microns. This allows it to observe early galaxies and faint objects, and reveal their spectra. With the help of microshutter array, which has 248,000 tiny shutters, NIRSPEC can block bright objects like a coronagraph does, and collect spectra of multiple targets at once. The maximum field of view of NIRSPEC is given by the 4 squares representing the quadrants of microshutter array. The 4 squares together make up an area of 3 × 3 arc minutes. Since it doesn't carry an individual camera, NIRSPEC will not employ any imaging modes. But, the 4 spectroscopy modes that will be put to use are slitted, multi-object, integral field unit, and time series. With this, we have seen all major details of Webb telescope's instruments. To have better clarity on which instrument of Webb has which component, visit our Twitter account and download this image. If you found this video useful, give a like, and share if possible. Give subscribing a thought. Bye everyone, see you soon with a new video.